Okay, sorry. We're going to do the problem with the hyperbola off center. Example 106.2. And let's just remind ourselves, here's our hyperbola information. So this equation looks just like the ellipse, except there's a subtraction, a minus sign in between, and we'll adjust with the h and the k. John is challenging us with the same type of problem. He's giving us the general form, and he wants us to switch it to the standard form. So here comes the general form. All the numbers are shoved on the left. X squared, y squared, x, y, plain number. So the first thing we want to do is rearrange, just like we did last time. We want to rearrange it so that the x's are together and the y's are together in the same set of parentheses, and we're going to kick the plain number to the curb. 9x squared plus 18x, they go together. And I leave a little gap, and I also praise the Lord that I can pull a 9 out of both of those. That's going to be fine. And then we're going to add minus 4y squared minus 16y. Okay, that's going to be fine too. Leave a little gap, equals, the 43 will change sides and become positive. Beautiful. Okay, now we're going to factor out these ugly coefficients. X squared plus 2x, and I'm going to pull out a minus 4. So I'm going to put that in parentheses, but next time I will change that plus into a minus sign. Minus 4, and then I'll have y squared minus 4y equals 43. It's always a good check to stop here and go, wait, I did something to this side, but I'm not doing it to that side. Is that okay? Yes, we're just factoring. We're not adding or changing any numbers. All right, this looks great. Oh wait, this should be positive, right? Because we factored out a minus 4. So this goes positive for us. All right, now we're ready to do some magic numbers. This is 2 divided by 2 squared, draw the arrow. That's 1, 1 squared is plus 1. Before I add it over here, I'm going to remember, oh wait, I have to multiply. I'll do that in the next step. Over here, my magic number is 4 divided by 2 squared. Draw the arrow. This is 2. 2 squared is plus 4. Now, I'm just going to underline those so I remember to go back to them. Now, what I need to do is multiply that out, because I'm not just adding 1, I'm adding 9. So this is plus 9. And over here, shoot, I added 4 here, but I'm actually subtracting 16. So this becomes, let's see, that is 52 minus 16 is 36. Ooh, that's a nice number. I'm happy with that. All right, beautiful. Now we're ready to collapse these trinomials into perfect squares. We know the numbers inside the parentheses are going to tell us what we need. We know we're still going to have these coefficients. So I have 9 times x plus 1 quantity squared. And then I'm going to subtract 4. I'm going to drop that minus sign, times y plus 2 quantity squared equals 36. Beautiful. Our last step is to set the right side equal to 1, so we have to divide away whatever's over there. Each term, and John usually sets these up quite nicely for us. So now this will cancel, and I'll get x plus 1 quantity squared over 4. 9 over 36 is 4. And then this is going to be a minus. I know those will collapse, So I can just write this, y plus 2 quantity squared over, that'll be 9 equals 1. Beautiful. And then as we did last time, it's really nice to write these as the perfect square rather than just a plain number because it helps us with our graphing. So this is going to be x plus 1 quantity squared. Oh, sorry, I got ahead of myself. This is 2 squared minus y plus 2 quantity squared over 3 squared equals 1. So that is the general form. I'm sorry, no, that's the standard form. We were at the general form. Standard makes us want to stand up and graph. And we can see here that our center, I'm going to write this on the top of the next page, just like last time, but our center is at -1, -2. Okay, I'm going to copy this to the top of the next page. And off we will go. Are you ready? Okay, so what does that tell us? Well, we have to think about how we graph these wild little ellipses, or hyperbolas. They're different. We have to draw that box, right? Okay, so what we're going to do is we're going to recognize that the center is at -1, -2, and that 2 and 3 represent the lengths of the box that make the asymptote. Let's draw ourselves a nice big picture. So just like we did when we graphed the hyperbola, we're not going to try and find the exact points. We're going to find the distances between things because those we can accurately write without having to make a bunch of extra calculations. The center is -1, 2. Now, the way we graph a hyperbola is we use these numbers to draw the box. So the box is going to be 2 units positive on the x-axis and 2 units negative. It doesn't matter that our center isn't 0 anymore. We're just going 2 this way and 2 that way. Then we're going to go, I'm going to make them a little bigger. Then we're going to go 3 that way and 3 that way on the y-axis, because 3 is associated with y, and this allows us to draw our box. And then remember, we use the box to draw the lines, right? I have to tip just a second to draw the lines. And remember, these lines are what guide us through the sketching out of the hyperbola. The lines we draw, we've drawn the box using these 2 numbers, 2 units on the x-axis, 3 units on the y-axis. There's the 3, so we did 3 on the y-axis. Then we draw the box around that. Then we draw the asymptotes. Now, we need to then use this to draw the hyperbola. So it's going to be like this and like this, right? And all of this is not affected by the fact that we are off center. Okay. We're good so far, but we also have to, John asked us to graph the equation. Okay, we have done that. We know that the length of this box is 4 because it's 2 and 2, and we know the length of this box is 6 because it's 3 and 3. But John also wants us to find the equations of the asymptotes, these blue lines. All right. That's going to be a little bit trickier because for that we need at least 1 pair of points. So let's first find the slope of the asymptotes. Asymptotes is how it's pronounced. Accent on the first syllable. This one, now I can count from here to here. It's up 3 over 2. So it's going to be 3/2. And then the other one, right, that's the positive slope that's going up, right? Imagine the little girl in her car. Well, she's not a little girl. She must be at least 16 because she has a driver's license. Unless she's a toddler runaway. That would make a great story, wouldn't it? Never mind. Okay, then we need the slope of this one, which is going to be negative. And again, we can go from here to here. It's going to be negative. It's going to be sink over the run, so it's going to be negative 3/2. Okay, that's going to help us find this. But we also need 1 point. On the asymptote. 1 for each line. So we're going to have to do a little bit of calculating now to figure that out. We know this center is -1, 2, right? That's the very center. So if we went 2 points this way, we would be at +1. Wait a second, it's -2. I was right. I wrote it correctly here, but I wrote it incorrectly here, didn't I? And then here is also needs to be the negative, all right? So the point on the upward, let's do the upward thing first. If this is -1, then our x value increases by 2. So that's going to be 0, +1. And then if this is at y equals -2, and then it goes up, it would go to -1, to 0, and to 1. So the point that we can use to help solve for our positive asymptote is 1, 1. We figured that one out, okay? We need to know this point. Most of these points we don't really have to describe, but that's how we go about converting it. Now we're going to go from here down to this point. Okay, our x is at -1 here. So we can see we're going to go to 0 and +1 again, but our y value is going to change. This is -2, so we have to go 3 further down, -3, -4, -5. So that will be the point associated with our negative asymptote. Notice how I carefully matched the slopes with the point, right? The upward slope is at that point. The downward slope is at that point. I can use the point -1, -2 for either of them if I needed to, but because it's the same, I'm not sure why that would not work, but these points are the ones we want to use to find the slopes of our line. So we're doing y equals mx plus b. And so for the positive slope, we're going to say 1 equals 3/2 times 1 plus b. And for our negative slope, we're going to say -5 equals, that's y, our m minus 3/2 times our x, 1 plus b. So this is our positive slope, and this is our negative slope. The two asymptotes, right? One has a positive slope, one has a negative slope. If that helps you, put a big plus there and a big minus there to keep you straight which is which. All right, now all I have to do is solve these two little dogs, and I will have the equations of this line. So I'm going to pull this out. We're going to need to look at it again in just a minute. I'm still using the blue ink to remind you that this is the calculation we're doing to find the slope, the equations of the asymptotes. Right, so this side is the slope, and then this is 1 point. And I've matched them up together, and then I plugged them in over here. Okay, ready? So let's solve the first one first, the positive. 1 equals 3/2 times 1 plus b. This is 3/2, so if we subtract 3/2 from both sides, it's going to cause an existential crisis here, so let's turn him into 2/2. And we get -1/2 equals b. So the equation of the first asymptote is y equals 3/2 x minus 1/2. That's the equation of the positive asymptote. Now we will do the negative asymptote. I'm saying it wrong. Asymptote. How many consonants can you have in a row? Okay, and so for the negative one, we're going to do, what did we say? Y. It's on this page. Here, let me copy it. Right, here's our positive slope. We just finished that one. Now we're doing our negative slope. It's -5 equals -3/2 times 1. Whoops, that's our x value. I was thinking about that as I wrote it, and I said x instead of 1. This is what happens. My brain conversation interferes. All right, this times 1 doesn't change anything, so I'm just going to cross that out. We're going to have to add 3/2 to make this come out. We're going to have to add 3/2 over here. This is a bit of a mess. We don't want 5, we want a fraction over 2. So let's make that -10/2. This all cancels, just like that did. I didn't cross that out. -10 plus 3 gives us -7/2 is our value for b. And so y equals -3/2, that's our negative asymptote slope, -3x minus 7/2. Let me put this in a box. Sorry, I got distracted. I never did that. This is the equation of the negatively sloped asymptote. Asymptote. All right, so this is our answer like this. Let me check. -7/2, that's correct. +3x minus 1/2, that is also correct. All right, let me go back and make sure our picture is correct. There's our center, our box is drawn correctly. All of this is good. The calculation of the asymptotes is exactly the same as when our parabolas are on center. The only thing that gets a little tricky is when we calculate the points to use in our calculations to come up with the line, the equations of those two lines. We have to carefully calibrate from our center, and then we can use the slope, which will always be laid out because we have these numbers, the 3's and the 2's. So we know exactly how many units to go up and then over to get the new point. We just have to calculate those to come up with these points. That's the only thing that's new in this process. Well, I, for one, am relieved that we have finally sorted out how to move ellipses and parabolas off the origin, and now we can just float those shapes all over the grid anytime we want. We have power and strength. That's the end of 106. Thank you. Goodbye.